So we are moving on with topics. Our next topic is systems of equations. We've spent about 2 months working on linear equations. We're now going to move to a system of those equations. So what exactly is a system of equations? So there's not a spot on your notes for this. So write it at the top, write it on the back, circle it. This is super important that you understand. What is a system of equations? A system of equations is a set of two or more equations in the same variable. The reason why I say two or more is because as you move on in math, you'll see more than two. For this year and next year, you're only going to deal with two equations. We say in the same variable, so underline same. The typical variables you're going to see are something like this. This is a system of equations. It's two equations, okay? You might see A and D. You might see S and R. Because when we apply to the real world, we'll use different variables. But the fact of the matter is, the system, okay, they have to have the same variables in order to solve them. So let's go through. I said we have to have the same variables to solve. Well, how do I solve a system of equations? What is the solution? A solution to a system of equations is an ordered pair. Remember, this is an ordered pair. The first number is x. The second number is y. Okay? So the solution has an x and a, which is your input, so you might want to put that in parentheses, and a y, which is your output. Now, that ordered pair, x comma y, it must make both equations true. Okay, so that's what this video is about. So your top of your page should look like what I have. Here's what we're going to do. Each problem involves work. There is space at the bottom of your page to do the work. You need to write in anything that is typed or said that is important, and we will be looking for that. So here's how we do this. I've got two equations. That is a system, but I have three ordered pairs. Not all three of them can be a solution. So I need to test it. Let's start with this first ordered pair. What I'm going to do, that's x comma y. I'm going to take the first equation and I'm going to test it. Okay, so write your equation on the bottom. Here's how we test it. I'm going to replace the x with its x value and the y with its y value. They both happen to be 0 here. Then I'm going to do the math. I didn't do anything on the left. All I'm doing is 4 times 0, which is 0. Well, 0 minus 1 is -1. Does 0 equal -1? No, it does not. Since 0 does not work on the first equation, I don't need to even bother testing it in the second, because remember, my solution must work for both equations. So since it didn't work for the first, I'm done on that one. So let's test our next ordered pair. Okay, this is a little different now. Again, I'm going to go with the first equation. I'm going to plug in 7 to my y and 2 to my x, because that's what this is. These ordered pairs are solutions to these equations. That's what the x and y are. Now here's what I'm going to do. I'm not touching that 7, I'm moving it down. I'm going to do 4 times 2. Okay, 4 times 2 is 8. Bring down the -1. Well, 8 minus 1 is 7. Does 7 equal 7? Now, notice this left side. All I did was bring it down each time. My goal was to do the calculations on the right and try and get it to equal the left. So what we're looking at is we're not going to force it to work, okay? But since it worked for the first equation, I must test it for the second. So please underline, you must test it for the second. So what that means is I'm going to take the second equation in my system. I'm going to plug 7 in for y and 2 in for x. what happens is I have 7 equals negative 2 plus 4. Does 7 equal 2? No, it does not. So since it does not work for both, it is not a solution to the system. Meaning, I need to test my last one. So we start at the beginning. I replace y with 3, x with 1. Then I'm going to have 3 equals 4 minus 1, 3 equals 3. Okay, look. My left side, I just brought it down each time. I'm not doing anything but bringing that down. Okay, don't change it. There's nothing else to do with it. So since it worked, and this should say here, this should say 1, 3. So since 1, 3 worked for the first equation, I must test it in the second equation. So then take a look. I replace y with 3, x with 1. So again, the 3 is not being changed. I just have negative 1 plus 4, which is 3. Therefore, that is what we should circle. That is the solution to this system. Okay? And I need you to write this in somewhere for this problem specifically so that you know it worked for both. Since it worked for both, it is a solution. So you need to pause now and try this on your own. Remember what I did. I first started with the first equation. I plugged in x for x, y for y, and I did the math. If it doesn't work, move on. Don't waste your time on the second equation. Okay, so I hope you've done this because I'm going to go through it rather quickly. So we started with 3, 6. I'm going to replace 3 with x and 6 with y. I'm going to do the math. 5 times 3 is 15. 2 times 6 is 12. 15 minus 12 is 3. 3 does not equal negative 3. So it's not going to be a solution. Since it does not work for the first equation, you do not need to test it for the second. It did not work. So let's now try 1, 4. I'm going to replace it. 1 is going to go in for x, and 2 is going to go in for y. So 5 times 1 is 5. 2 times 4 is 8. 5 minus 8 is negative 3. Does negative 3 equal negative 3? Yes. So then we have to test it in my second. Again, 1's going in for x, 4's going in for y. 5 times 1 is 5, plus 4, 9 equals 9. The ordered pair works for both equations. Therefore, it is the solution to this system. You don't even need to bother with negative 1, 1. Okay? And you'll see tomorrow in tomorrow's video that the solution to a system is a point that works for both. It overlaps on both. And we're going to do that with graphing. And it's okay if you don't get it.